Let's move on to the next part now. In this lecture, we are going to be studying the expression for the equilibrium constant with some examples. Let's move on. Our first problem states that nitrogen reacts with oxygen to form nitrogen monoxide according to the equation as shown on the screen. As you can see, we have a balanced chemical equation where 1 mole of nitrogen reacts with 1 mole of oxygen to form 2 moles of nitrogen monoxide. Try writing this expression for equilibrium constant for this reaction. First, we write down the rate expressions for the forward and reverse reactions. This step is not mandatory when you are asked to write the equilibrium constant expression, but it may prove helpful for your understanding. Next, for the rate of forward reaction, it is equal to Kf multiplied by concentrations of nitrogen and oxygen, since they are reactants and are both raised to the power 1. For the rate of the reverse reaction, it is equal to Kr multiplied by concentration of nitrogen monoxide raised to the power 2. Finally, let's recall the Kc expression. It is the ratio of product of the concentration of product raised to the powers equals to the number of moles in the chemical equation to the product of concentration of reactant raised to the powers equal to the number of moles in the chemical equation, right? So, for this equation, Kc is equal to the concentration of nitrogen monoxide raised to the power 2, as its coefficient is 2 in the chemical equation, divided by the product of concentrations of nitrogen and oxygen, both have power 1 as their coefficient is 1 in the chemical equation. That is your answer. Pretty simple, isn't it? Let's try another example. In this reaction, nitrogen and hydrogen react to form ammonia. We have 1 mole of nitrogen reacting with 3 moles of hydrogen to form 2 moles of ammonia. Similar to the previous example, we must first write the rate expression for the forward and reverse reactions. For the forward reaction, which is equal to Kf multiplied by the product of concentrations of nitrogen and concentration of hydrogen raised to the power 3, as 3 is the coefficient of hydrogen in the chemical equation. For the reverse reaction, the rate is equal to the product of Kr multiplied by the concentration of ammonia raised to the power 2, as its coefficient is 2 in the chemical equation. Now, let's move to the next step, the Kc expression. Kc is equal to the concentration of ammonia raised to the power 2 divided by the product of the concentration of nitrogen and concentration of hydrogen raised to the power 3. This will be the equilibrium constant Kc expression for this given reaction. Keep on practicing and you will get better and better. This marks the end of this lesson. In our next video, we'll discuss the unit of equilibrium constant.